All right, so workplace 30, and this is 7.1, part 2. So this is number 2 of 2. And we're talking about trigonometry, we're talking about the sine law, and here we have a situation where there's a diagram here. The situation, we have a tree that is not completely vertical. So this is not a right triangle. This is a triangle that has an angle that's a little less than 90 degrees here, when sometimes that would be exactly 90 degrees, right? But this tree is leaning over a bit. So the question says this: Miguel is an arborist, and an arborist is someone who trims trees and cuts down trees and does all that sort of stuff to do with trees. And he needs to calculate the height of a tree that he will be removing from a construction site. The tree is leaning at an angle of 85, so there's our angle of 85, with the ground. Miguel stands 30 meters from the base of the tree and calculates the angle of elevation, which is right here, to be 32. So what's the height of the tree? This is 30, right here. So here's our situation. I have a triangle that's not a right triangle. I'm trying to find this length right here. That's the height of the tree. So if we remember back, from our examples before, we can use pairs of angles and opposite side lengths, right, to create the sine law, or to use with the sine law. So it looks like I'm trying to find m, so I'm probably going to use 32 there, right? But I do not have the opposite side here to 85. So I can't have two pairs of sides and angles. I can't have two that each of them have an unknown. That's no good. So I can't use that side right now. So what do I have to do in order to use the sine law? Notice I am given this side right here. So I need to have an angle and opposite side pair. Find the angle for the top. Very good. Okay? And of course, when you're given two angles of a triangle, you can always find the third. So this angle T right here, angle T, is 180 minus 85. That's this angle, minus 32. So what's 180 minus 85? Well, that's 95 minus 32 would be 63. 63 degrees. And of course, the solution, you'll have the solution below. And so they've calculated 63 in that same way. But that's how they got that. That's why they did that. So now we can use the sine law here because we have an angle and its partner opposite side. Okay? So we're going to set that up just like this, and I won't rewrite it because it's right here. So sine of 32 over unknown side m equals sine of 63 over the known side of 30. And so when we cross multiply, and you can switch values across the equal sign top to bottom, excuse me, we're going to be able to solve for m here. And m, when it's all said and done, is 17.8. Okay, and we've done calculations like that, I think, before, so hopefully you're okay with that. So why don't we do a question that doesn't have the answer in front of you, and let's work through this together and see if we can figure this out. So this one looks maybe a little bit complicated because it appears that we have multiple triangles, and there's pieces of information all over the place. So let's just read and see what it says and see how we might want to tackle this. A communication tower is stabilized with guy wires. So these wires that are attached to points on the tower and then attached to the ground, an anchor on the ground, are called guy wires. One wire is 3.7 meters long, and that's labeled on the diagram here. And a second guy wire is attached to the pole 1.25 meters higher than the first. So that's where this information comes. The first one's attached here, the second one attached 1.25 meters higher. But it's attached to the same anchor point on the ground. The angle between the two wires is 10 degrees, and that's labeled right here, between the two wires. What is the length of the second wire? So what you should notice here is that we do have a pair of angle and opposite side, right? We have one of those. We have 10. So here's this angle, 10, along with this opposite side of 1.25. See that? Okay. But because this is not a right triangle, I cannot use Pythagorean theorem, right? So that's out the window. I need to try and figure out how I can use another pair there. So I have this side Um, so, I don't know. I don't have this angle though, and I'm trying to find this one. So with this one, we might have to do stages. Yeah, do you have an observation?
That bottom corner, is that 90 degrees?
This one probably is 90 degrees here. Yeah.
Okay.
So you're seeing another triangle here, aren't you?
And then
Okay.
we find the top angle and then do the 180 minus top angle to find
Oh,
the
okay, okay. So, okay, so we have some options here for sure. So you're talking about this angle right here. Is that right?
Oh, I'm talking about the bottom.
No, this one's 90.
That one's 90, and then
Yeah.
the one that intercrosses, that top one of the second of the smaller triangle.
This one?
Yeah,
What's that one?
we don't know. We could use the 180. No, we can't. I don't know.
Yeah, so this is a problem. We don't have this and we don't have this. We have 10, but we don't know what this is. So if you're seeing a 90-degree angle here, that's cool. Can we, what do we have here? I don't know. Like, we might be able to use this somehow.
The right. We could use the
See, I don't have this angle and I don't have this angle. So I think we're a little stuck with that right angle there. You see? I don't have this length, so I can't use Pythagorean theorem. Can I find this side? I don't know this angle, so I can't use trig functions there. Okay, so let's go back to where we were before. Those are good thoughts.
You can still find out the length underneath the 1.25 meters though. Because if you know the 2.5 meters and 3.7 meters, you can find out that one.
Okay, so if let's go back to that then. Let's go back to that. Let's go back to that. Okay, so it is noted here that we have this side of this smaller triangle, and we have this side of this smaller triangle, and this is a right triangle. So we could use Pythagorean theorem to get this, if we want.
What?
That's true. Thank you for that.
Sorry.
Okay, is that going to help us?
Yes.
That will give us this whole side here. I guess then we could use Pythagorean theorem to find this, right? So that we could totally do that. We could. Here's the other suggestion. This is the other way you could do that. You could use the right triangle. So thank you for that. But if we focus on this smaller triangle again, let me just erase all this stuff. If we focus on this smaller triangle, okay, we have this, and I have this, so that means I can solve for this angle right here. I can solve for that. I can use sine law to solve for that. If I get this angle, I can then get this angle. Then I can use sine law again to find this side. So there are multiple ways to do this given the information that we have. That's for sure. So let's, instead of using the trig functions and Pythagorean theorem, let's use the sine law that we're learning in this section. Okay? So, back it up. Let's do this. Sine of 10 degrees over 1.25. That's the opposite side of this triangle that the 10 is in. Equals, now I'm going to find this angle. Let's make this angle x, okay? So sine of x over this side length is 3.7. See that? All right. So I'm going to multiply the 3.7 up there. That's going to be multiplied by the sine of 10 degrees. And I'm going to fill that in. I'm going to have sine of x. So then I'm going to have sine to the negative 1 of this right here. And that's going to equal x. So remember, when we're solving for an angle, we use the second function part. Okay, so second function sine, that's the negative 1 there, of, and you can just put this all in if you want. So I'm going to use bracket 3.7 times sine of 10, bracket, I guess another bracket, divided by 1.25. 1, 2, 3, 1, 2, 3. We have the same number of left brackets and right brackets. I might have used one too many, but I'm just being sure. So it looks like 30.93, or let's say 31. So x to the nearest degree is 31 degrees. So did everyone see that that's 31 degrees here? Oops, 31 degrees. So that looks pretty reasonable. I mean, if this is anywhere near to scale, that looks like it could be 31. So now we have a new pair if we want. And I can then find this angle, can't I? So this angle, let's make it red and make it y. y is 180 minus 31 minus 10. So 180 minus 41 is 139. So there's lots of pieces here, there's lots of steps. And remember, just take what you're given and find something. Find anything. And then put that on the diagram and look at it again. And say, okay, now that I have that, I actually can use that and find this. Then find that. Keep finding things until you can see that, hey, now I can get what I really want. So now I can use any combination of angle and side with this new combination of angle right here, 139, and this unknown side. And that's really what we're trying to get to. So the sine law, as I mentioned the other day, I haven't really done it yet, but we could flip the side lengths and the angles, the sine of the angles, we could flip those around. So let me show you what that means. I could go like this. I could go 3.7 from here over sine of 31. You can do it this way too, as long as then you keep the signs on the bottom and not the top for both fractions. So then I have, what is this? Unknown, question mark, over sine of what? What's this angle again? 139. And then this actually makes this math a little easier, because all I have to do is take this up there and multiply this up there, see? So, just to be sure that you know what we're doing, so this is sine 139 now times 3.7 divided by sine 31. So this is big kid math now. This is big kid math. Big kid math. It's going to be, well, I'm not saying you were little kids before, but I'm saying this is definitely big kid math, because there's multiple steps here. You really got to use your brains here, man. This is serious. So don't feel bad if this looks like to be a little complicated. That's okay. So sine 139. Hey, you write this down? You should be writing this down probably. Times 3.7. Okay, you got an answer then? Potentially. Divided by sine of 31. Okay, so do we get 4.7? 4.7, let's make sure we have units on there. All the lengths in this question are in meters, so let's use meters, and I'll erase some of this stuff here. And of course, we are now done by solving for this 4.7. That's the length of the other wire. Okay, so here's some other questions for you to do as well. I'm going to give you, I'm going to do another example with you here. Okay, so I'll just show you these questions here, and then we'll move on to our next example. You can finish these later in the class or another day. But these are some practice questions for that type of question. So let's focus on example 5. So we'll skip ahead a little bit here. Example 5. You can go back to those other ones in a bit. Another type of example. So how is this one different? Let's see. Kareem is sewing a sail for a toy boat. The sail will be made of 2 right triangles. So I can see one right triangle here with A, B, C, and D. Sorry, A, C, and D. And A, B, and C. Okay? 2 right triangles right next to each other. He's cut out the material for ABC, and angle B is 72. There's 72. He knows that side AD, okay, so AD is the side that connects point A and point D, right? That side length is 9 centimeters. And the base of the finished sail must be probably the width of the boat there, right? So it must be 7.8. Okay? So something like this. 7.8. At what angle must he cut angle DAC? So that one is, see, this is how you do this. Angle D, go to D, then to A, then to C. So that's this angle right here. Okay? DAC. It's not this one, not that one, but it's DAC. It's the one that's made by D, A, and C, this one. Okay? So go D, A, C. All right, because I think some students going to get that confused. They just say, see D, angle D, oh, ED right here. No. DAC, it's this one. Okay. All right, so we need to figure that out. Boy, how can we figure that out? Well, I don't know this angle because this is a right triangle. So if I knew this angle, I could probably, just do subtraction here and do that. Well, what can I find out? Is there anything that jumps out at you? Anybody?
The other side of the angle for A.
Yeah, you could find this one, I guess, right? You could find this angle because we got 72, 90, and then unknown. So you could do that one. Would that help?
No. Yes. No.
Okay. Well, let's see here. I've got an angle and an opposite side, right? I could use this opposite side and find this combined angle here. You see? I could probably use this pair and this pair with the larger triangle. And then, if we did what you said, if I knew this whole big angle, I could find out what this little angle is and then subtract it from the big one to get me this one. So I think sine law is going to work for us here. So let me show you what I mean there. Okay. So if we did this pair, that is sine 72 over 9, and then I tried to find big angle A here, like this whole thing, I could do equals sine A over 7.8. Everyone see that? Can I write that down? Yeah. I guess this is an example, so I guess you do have the solution there on the next page, perhaps. So let's just see if we can solve for this sine A. So sine of 72 times 7.8 equals, divide that by 9 equals 0.8242. Okay. So watch this. Sine A is 0.8242. And now I'm going to do second function sine of the answer of that decimal to get me 55.5. 55.5. So that's this whole big one right here, 55.5. Everybody good with that? So now I think I like what you were saying there, Curtis, about finding this little angle so we could find this one. Because I think that would be a good way to go now.
Wait, so the whole top one of A equals 5?
Yeah, 55.5. That's the whole thing here.
Oh.
The whole thing. All right? So then if we find this little angle right here, by doing this angle right here is 180 minus 72 minus 90. And what's that going to be? 62, so 20, 18. 18 degrees. So this is 18. And so 55.5 minus 18 is 37.5. So it looks like this angle here is 37.5 degrees. And I think that should be your answer, right? That's what you're looking for.
Wait, where did you get the... Is that a 70 or a 90?
This one? This one.
The one, yeah. That one.
That's a 90.
Oh,
That's from here. Sorry, yeah, it's not 70. No, it's a 90. Yeah, no,
Sorry.
it's a 90. Okay, so I'm just going to check the next page here because I think this one. Now they may have done it just a little bit different order. I'm not really sure. Yeah, I think they did a lot of the same there, didn't they? Except they rounded this instead of 55.5, they rounded it to 56, which is fine. And so their answer was 38, and ours was 37.5, wasn't it? Whoa, where was that?
I have a question about what
It's a good question. I'll accept both of these answers, really. To the nearest degree is acceptable, but to the nearest tenth would be even better. Okay. So, any questions about that one? All right. So we're kind of at the end of this second part. Then there's number 8, a question you can do, and number 9, a question that you can do there. Going all the way to 9b. And then we're at the end of this section. So that's the end of this section. Once you're done those build your skills, you can work on these practice, and that will give you sort of a chance to practice questions from both parts of this section.